The current manufacturing framework, as you can see, first we had the first industrial revolution, which started with the steam-powered mechanized production, and the second industrial revolution, all of you know that it came with electricity powered. Then the third revolution, which came with the IT automated production, which was the actually when the computers came in actually. Now we are actually dealing with the fourth industrial revolution, which we're trying to incorporate within the Pakistan industry also. And it involves the digital automation and the other human resources and the production tasks. So if we see this digital disruption, these are some of the areas which are actually required for the digital consumer, because nowadays a customer who needs certain information for all of these areas. For example, we talk of the new product design, talk of the product and the production, and we talk of the supply chain, talk of the digital manufacturing. Some of the people talk about the supply chain also, additive manufacturing, governance, logistics, digital engagement. You take the aftermarket areas also that has to be actually looked into for a digital customer. So if we see in this one, what we need to have, we need to provide to the digital customer or the customer or the organization, that is, we have to have the connectivity, we have to need the computing power and the automation. Unless all of these, three of these areas are connected together, we won't be able to support the digital customer. That can be the customer, that can be supplier, that can be the logistics and supply chain. Although some of these are working in silos separately, but when we need to integrate certain environment, we need to have a strong computing power also. We need to have certain connectivity and the automation within the organization, on the shop floor, within the organization itself, for the different entities, for the different departments within the organization. Unless we don't have these things available within any organization, totally we won't be able to embrace the digital manufacturing. That would be a lag into that. Current manufacturing transformation, we see that currently till 2025, 98% of the manufacturers trying to engage themselves in the digital transformation. And this is 78% up from 2019. If we see the global market, right now it is the $1 trillion growth there, but it is expected that by the 2034, this growth will go till the more than $15 trillion. So there is a lot of potential available for all the industries to embrace digital manufacturing. Although you cannot embrace totally, but we can have to create certain islands of automation also. And we see that the 30% of operating budgets which are allocated towards the digital technologies right now, and we see that the 65% of the manufacturers, usually they are trying to scale their pilots into the full programs. Initially, they are doing certain pilot projects and then converting into the wholesome system. If we see the effect on the performance, if we embrace the digital manufacturing, the organization embrace into that, we'll see that there would be 53% increase in labor productivity as per the World Economic Forum. We can see that the Global Lighthouse Network as per the reported. And we can see the 50% improvement in agility. Right now, the agility is very, very important. You have to, change yourself quickly as per the market requirement, as per your competition. The change has to be there. If the organization not able to change itself, not going to able to compete in the market, put its product in the market, they won't be able to compete. They will have to lag behind, because global competition is reaching to every part of the industry. Okay, then we have a 26%, more than 20% reduction in the manufacturing conversion cost. Manufacturing conversion cost, all of you are very well aware of that from the design to the product itself, that conversion cost through the processes, we go through the process, all that. Then why we need to embrace it now? Because right now, global market competition is there. You can see that we have the volatile market, we have the talent shortages because all the experienced people within the manufacturing industry, they are retiring, they are going, and have to take their knowledge and incorporate into certain technologies. For example, you take the example of the process planning itself. Previously, process plan is made by certain expert in the industry, but if we convert that into the computer-aided process planning, all the processes which are given by the technologists, by the people, expert, they can be transformed into the computer process planning, which can be saved within the plans. And then the technology affordability, with the passage of time, we know that computers and technologies are becoming more and more cheaper, and the industrial Internet of Things, they are becoming more and cheaper. Sensor and cloud computing, edge computing is a need of today, which is the cost is dropping 40% since 2020. And the competitive imperative that the most of the 65% of the global manufacturers scaling pilots into program. So first of all, they try to create a pilot, a small project, then implement at the organizational level. So key differences, if you can see between the conventional and the digital, there are actually different areas, aspect. We can have decision making. Previously in the conventional, decision making was totally different. It was experience based. Now in the digital manufacturing, it has to be data driven or the predictive. Similarly, the quality control, you can see that previously we had to have the manual inspection. Now we have to have certain inspection, online inspection have to be there. Certain people, for example, previously a few days back, the biscuit manufacturing line, most of the time you see on the production line, people are manually actually arranging or picking up the defective biscuits. So now the solution are there. Some of my students have worked into that, gave solution to the industry that in the real time how to trace out the broken biscuit or the more cooked biscuit and remove it from the line. Although these type of solutions are implemented in other areas also. Regarding maintenance, we have to have scheduled maintenance previously, but now the predictive maintenance, similarly flexibility, that is very, very important thing, flexibility, which one can achieve by implementing digital manufacturing within the organization. It could be adaptive and reconfigurable actually. Data usage. Previously, we have a limited data usage, but with the implementation of machine learning and other techniques, you can also integrate different data. I won't go much into detail of these pillars, although they are considered to be to implement the digital technology and the architecture. They are usually considered to be the 9 pillars. But the most important of those 9 pillars are the industrial IoT, Internet of Things, then the artificial intelligence, machine learning, digital twins and simulation. That is also very, very important. Although digital twin could be for a single machine, for a line, for a system itself. So it all depends. Right now within Pakistan, not much work is done. Only probably we're at academics level, probably we are working into that area. I have seen in the merchant navy, probably I have seen that they have certain implementation of the digital twin. They have certain simulators where they can do that. Additive manufacturing, that is another area. Since morning you have seen that a lot of emphasis is on the digital manufacturing, but that is still a one pillar of the digital manufacturing. That is not in totality, is not there. So although that is important thing, but that is not the whole. If we want to embrace the digital manufacturing, we want our organization, industries within Pakistan to modernize themselves, to compete with the international, the standards, international competition, which is coming in very rapidly, very quickly, especially from, we can see from the China and other countries also. Automation and robotics, that is another area without which we cannot implement actually your solution on the shop floor itself. This is a small actually implementation strategy which is called the Neodyme proven framework. It does that digital transformation and the front end study. That is very important when you have to implement that, what you need to do. You need to go through the complete organization scenarios. What are the scenarios there and what are their problems? You have to study that. Then you need to see what is their requirement there, what are the resources available there. Doing all the analysis of this certain organization, after that only you can create the problem statement. Even within the problem statement, because there could be 10, 20 problem statement can be there, but you cannot attack on them at once only. You have to go one by one, and there you have to see that if we solve this problem, what would be the solution, would be how it would be implemented, what would be the output of that one. Once you prove that particular value of that particular project, if you see that still needs certain iteration, it will go back to the problem definition. Once you have decided that problem definition, then you will create a prototype, a small. Then on that prototype basis, you have to implement that solution within the industry. So that is actually, a reference is also given there. If somebody like to have, I can give it to him. Return on investment, this is the implementation, all the Finesta windows and doors. The case study is not within Pakistan, it is for outside Pakistan, but it has seen that they had the challenge of manufacturing processes and the quality inconsistencies and the production bottlenecks. The solution was given to them using IoT sensors, twin technology, digital twin technologies, automated quality control. And what was the result? Result was, you can see that we have the 15% reduction they reported in reduction in the production time, and the 12% in the operating cost, and 25% improvement in customer satisfaction. The most important thing for any kind of industry who like to invest for the digital manufacturing would be when we are going to get that return. When is going to be the payback? Payback is very important. No industry would like to invest even 1 rupee until unless they see that we can have a payback. So you have rate on investment, you have to calculate that time, in how much time that investment would be recovered. Obviously that recovery will be from your own processes. Either you are reducing the damaged product, work in process is reducing, your capital investment stuck in the work in process is reducing, or your production time is reducing. It means you are able to produce more item in the same amount of time. So this type of small applications was done by me and my team for the fan industry. What we did that we optimized their production line, gave them certain solution. We did the simulation of the whole production line, and within 1 day, their 20% production with the same resources was increased. That fixed cost and the variable cost, although variable cost will increase with the raw material also, but the fixed cost remain the same. When the fixed cost remains the same, that cost will be distributed on the number of items. When it is distributed on the number of items, the cost per product will be reducing. So that is the actually simple phenomena. So we implemented that also. So advantages and challenges, operational efficiency, quality control, flexibility, cost, innovation, supply chain. But the challenge is there that for the operational efficiency, high integration cost is there. Similarly, for the quality control, you have the data management challenges, because if you have to control the quality of certain product, you have to have certain scenarios of that particular product. You have to have certain database that if, for example, when I did project for the production line for the biscuit, because the biscuit could be square, could be rectangular, its position could be different. It could be broken from any of the corners. It can have different color also, the baking time. So lot of database has to be required. We have to develop a certain database for that one. Flexibility, workforce, actually reskilling required. If you are not able to equip your workforce, you won't be able to implement these kind of technologies. The cost, obviously, initial cost would be there, but as I said that return on investment, ROI or the payback, that has to be calculated. So innovation, cybersecurity risk, somebody may attack and jumble up your system itself. Supply chain, as my previous speaker, he also talked about the supply chain. So we have to start with the comprehensive assessment and the planning. Then we have to engage stakeholders early, and then often we have to see that who are the stakeholders. We have to invest in training and change management. That is the key actually, because unless you train your staff, it is usually said that the guns are not important, the man behind the gun is important, because if he's not able to fire that, no matter how expensive your equipment is. Establish clear governance. You have to plan for iterative improvement. one model is there, and you have to do certain iteration for that and improve it further. Key challenges for Pakistani manufacturers are the adoption barriers, skills gap, infrastructure readiness, and the investment capacity. These are some of the barriers which we can see. Special barrier is the investment capacity and the skill gap. Until unless you are able to train your manpower, if you don't have that manpower, don't think of doing that. Don't think of implementing that. So recommended approach is start small. Don't start as a whole from the whole industry. You can start from a small portion of your industry. For example, you can start from the design department. From the design, you might be having a lot of, for example, previously certain like Miller tractor, they might be having hundreds of drawings there available, manual drawings previously there. If you have automated those drawings, you have all that 2D, 3D drawings available in the system, you can have a small database available with you. You can easily, trace back, and you can easily review those drawings. Start small from one portion. Leverage local expertise. Try to engage local expertise also. And government program, there are sometimes government is offering certain program, they are giving certain incentive, try to utilize that. Industry collaboration, one industry is strong in one area, other industry can collaborate with him, that is the, should be the approach. Skill development, investment in workforce, I again say again and again, investing on your workforce is the key thing. They can turn around the industry. So this is one example of regional success. This is about the textile industry in Karachi. They implemented through certain local company. Conclusion that is that embracing digital manufacturing is a strategic necessity, not an option. Now it has become a necessity. You cannot say that I don't want to do that till 10, 20 years, but you have to go step by step towards that. You have to start different phases. Data-driven approach, and you have to see that what is the return on investment you're getting, and the workforce enablement, that is the third key. Fourth, last one is the continuous improvement. When you are implementing on one particular area of your industry, later on you can do it for the others also. And the last but not the least is from the Steve Jobs. Innovation distinguishes between a leader and a follower. So if unless you have urge for the innovation, you won't be able to become a leader in the industrial sector also. Thank you very much.